All right, hello again, everybody. I just want to wrap up the final few notes on signal detection theory here before kind of tying them into what you're going to have to do for the seventh homework for the class, which is actually directly based on the results of this experiment that I've got up here. So before I get into all that, I just wanted to say that one of the goals of this particular exercise is to get you working with real data that you might collect from a perception experiment. So this is an actual real perception experiment that I ran a long time ago now with my colleague Suzanne Curtin at the time, and it was actually her brainstorm pretty much entirely. And the way this particular experiment worked, so Suzanne Curtin, her focus is on child language acquisition, including like how children learn how to perceive speech. And so what we did for this particular experiment was she came up with a series of sentences that were syntactically ambiguous. And then she wanted to find out, or we wanted to find out whether or not listeners could resolve the syntactic ambiguity if they if they could resolve the syntactic ambiguity better if they're listening to the sentence spoken in infant-directed speech as opposed to adult-directed speech. Kind of one of the suspicions being that infant-directed speech helps kind of transmit those syntactic cues to young children as they're learning how to acquire language, and therefore they can kind of get the basic building blocks of how syntax works when they're just listening to older speakers speak to them. So if you haven't guessed by now, and you probably wouldn't, I guess, but the syntactically ambiguous phrase that was at play in this particular example was, "and the peach colors on the wall." So in this one example over here, where it's maybe easier to understand, there's an anthropomorphic peach. Actually, there's a wizard who lives in a house that has fruit in it, and then when he leaves the house, the fruit are magical fruit, and they become alive, and the peach happens to color on the wall, much like my daughter does. But anyways, the other option is a girl moves into a new house, and then she visits her new room, and she finds that there are peach colors on the wall. Or I guess, yeah, maybe one peach color. But anyways, that's the phrase as it was read. So it could be either an adjective noun in a particular noun phrase like peach colors, on the wall, and then in this case it's a noun and a verb. So the peach is a noun, and the peach is doing an action. The verb is coloring. We had people come in, and we actually had mothers come in and read these short little stories about the girl moving into the new house or the peach coloring on the wall, both to their young infants who are I think under a year old, and then they also read the same stories to adult experimenters who were not under a year old. So we had examples of both infant-directed speech and adult-directed speech for the same sentential tokens, basically. I'm going to play you some samples. So there's kind of two questions at play here. One is, can you determine whether or not the speaker is speaking to an adult or an infant? And the other is, can you figure out which phrase the speaker is producing? Are they producing this adjective noun, peach colors on the wall, or are they producing this noun verb, peach colors on the wall? So I'll turn this up a bit, hopefully not too loud. And these are some real samples from that experiment. These over here, these two are spoken to the same target. These two are spoken to the same target, but one is going to be one syntactic type and one is going to be other, so on and so forth, the exact same way over here on the right. So we'll listen to these two first. Maybe you can tell me what you think. Actually, you can't tell me what you think, but you can think to me what you think. All right, here we go.
And the peach colors on the walls.
I'm going to turn that up a little bit higher. We'll play that one again.
And the peach colors on the walls.
And then this one.
And the peach colors on the walls.
So, maybe I'll play these two in contrast to these two over here.
And the peach colors on the walls. And the peach colors on the walls.
So I think kind of the easy part of the task is that you can determine that these two tokens were read to infants, right? These sound like infant-directed speech.
And the peach colors on the walls.
As opposed to this less exciting reading here.
And the peach colors on the walls.
It still has a little bit into it. But anyways, once you hear this, the other decision that the participants in this experiment had to make was like which cartoon does it correspond to. That might be a little bit trickier, but you can give it a shot. We'll listen to these two again.
And the peach colors on the walls.
Versus this one.
And the peach colors on the walls.
Yeah. Maybe I'll pause there. So on the left, the two options are that this is the this phrase, the adjective noun phrase.
And the peach colors on the walls.
And then this is the anthropomorphic peach coloring on the walls.
And the peach colors on the walls.
Maybe you got that, maybe you didn't. In the actual experiment for these tokens, 100% of people listening to this first one
And the peach colors on the walls.
identified it as a infant-directed speech token. Only 92% identified that as infant-directed speech. More people got the syntactic type correct for this first one as well.
And the peach colors on the walls.
Which is this one. Oops, sorry, no, it's this one. Sorry, over here.
And the peach colors on the walls.
And then this second one is the adjective noun phrase.
And the peach colors on the walls.
Right. So fewer people got that. Only 46% got the second one right in terms of its syntax, and 84% got the first one right in terms of its syntax. We can listen to these two again, and we know they're adult-directed speech, but we can try the syntactic type identification task as well.
And the peach colors on the walls.
Versus.
And the peach colors on the walls.
So I don't know if there's a whole lot of clues in there as to which one might be which.
And the peach colors on the walls.
I might guess that that's this one, this noun verb phrase.
And the peach colors on the walls.
And maybe that's that one's the adjective noun. I don't know what you thought. But that is in fact what it is. Again, most people got the target right over here. I'm looking down at the notes here on the slide. 58% got the syntax of this one right.
And the peach colors on the walls.
And I have an advantage because I've heard these a lot of times. But maybe you got it right too. Remember, chance in this case would just be 50%, just a random either or choice. A few more got this one correct.
And the peach colors on the walls.
With 73% correct across the board. Either way, it's a tricky little task. And like I said, the idea was, does infant-directed speech help people interpret the syntactic sort of structure of these phrases when they're kind of cut out of context like that? And, you know, based on these numbers, maybe they do, maybe they don't. We talked about sort of counting overall correct percentages, the number of responses that were correct responses, and the confusion matrices that we developed in walking through signal detection theory. And over here, we can kind of combine these into two in the same way. This is like 130% correct out of 200%, I guess, for both options. That boils down to an average about 65%. It's about the same here, too. This is about 131 if you add up 58 and 73. So it looks like people are doing fairly similar on these particular tokens, but how do they do across the board is kind of usually the statistical question we want to answer in analyzing our data. Before I move on to the results as I presented them a long time ago when I presented this at a conference somewhere, I will point out as well that listeners could replay the stimuli as many times as they liked. I've played these all several times for you in just walking you through this demo. But in the actual experiment, people could replay it multiple times before they made their decision, both about the target of the utterance and also the syntactic structure of the utterance too. And the order of the pictures was counterbalanced across presentations. That's just a technical detail about how to run an experiment, but you don't want to always have like the adjective noun phrases over here and the noun verb phrases over here. You switch it up randomly or actually balanced across participants, so you get an even number on each side. So here is kind of the raw percent correct data about how often people correctly identified each target type. And it's a bit of a funny way to look at it, because if they're not getting the target correct for, say, infant-directed speech, that means they're identifying it as adult-directed speech and vice versa. It would be kind of better to get just an overall D prime number for that reason. But what we see here is a greater number of percent correct responses for infant-directed speech than adult-corrected speech. And for both the percentage of stimuli that they correctly identify the target of is significantly higher than chance. We don't have the tools yet to actually know how to test that, but I'll get you to that before the end of the semester, I promise. But for infant-directed speech tokens, they were getting about slightly more than 80% of those correct on average, or on median, I guess you could say. And for the adult-directed speech tokens, it was slightly less than 80%. The difference in these two types was not significant. And again, I'm not going to walk you through what test we would have used to try to determine that. But for now, it's just suffice it to say that people did fairly well on the target identification task, but they weren't at 100% by any means, which is kind of interesting. So there are some cues that, to differentiate between an infant-directed and adult-directed speech out there that you can hear and pick up on, but you might not get those cues or identify them correctly all the time. The kind of more interesting question from the speech perception perspective is how well did people do on the syntax identification task. And remember as well, I don't think I said this explicitly, but our participants in this experiment were university-age students at the University of Calgary who are doing this for bonus course credit. So the way we boiled down the data is we converted this all into D prime scores. So each listener heard a certain number of adult-directed tokens and a certain number of infant-directed tokens. And then within each of those groups, they were boiled down as well into adjective-noun phrases and noun-verb phrases. So we were able to basically calculate a D prime score for each type of utterance, which represented how perceptually distinct were the adjective-noun tokens and the noun-verb tokens in their perceptual responses. What sort of sensitivity did they have to that distinction when they were trying to identify what syntactic type each utterance had? And it turns out that D prime is a little bit larger in terms of for the infant-directed speech tokens than it was for the adult-directed speech tokens. So again, just kind of looking at medians or averages here. So the median D prime for the infant-directed speech was about 0.6. And for the adult-directed speech, it was slightly less than 0.2. So that's a difference of a little over 0.4 of D prime, and you can think of that, I guess, in terms of like a standard deviation on that perceptual evidence scale. But either way, you can calculate a D prime score for each of these token types for each listener, and if you have like 20 listeners in each group, you can run a t-test comparing those D prime numbers on either side, and you find when you do that there's the t-test gives you a p-value of 0.003, so that's significant, which means that they're basically better at identifying the syntactic type of infant-directed speech utterances than they are for adult-directed speech. So yeah, we can conclude from that, on top of all that the properties of infant-directed speech provide some cues to syntactic disambiguation, whatever they might happen to be. So that's kind of a cool effect. So maybe infant-directed speech is structured the way it is, not just to sort of catch the attention of little kids or what have you, but also to teach them a little bit about the structure of what they're hearing. We also looked at bias in the same way. So this is the measure beta that I walked you through in the previous videos on this lecture set. And so interestingly enough, we get a higher beta score for the infant-directed speech than we do for the adult-directed speech. So 0 would be an unbiased criterion, and the adult-directed speech is almost right on top of that number. It's a little bit less than 0. Infant-directed speech is higher than that. It's maybe 0.3, 0.4 something. I'm just noticing this time that there are these crazy outliers up here where people are like super biased towards the positive end of the scale. Don't know exactly what's going on there, but they may not have been trying all that hard to do the experiment. But basically, the finding here is that we get a significant result here. Again, so we can calculate bias numbers by individual subject. We get like 20 in each set. You can run a t-test to see if they're different. And in this case, positive means a greater bias towards noun-verb responses, and you get more of that bias for the infant-directed speech. So yeah, I don't know if you felt like there was more of a bias there, or more of a sense that these sounded like noun-verb phrases.
And the peach colors on the walls.
Like corresponding to this story here.
And the peach colors on the walls.
But that's what we got from our subjects, right? So that's interesting as well. So not only is sensitivity greater for infant-directed speech, but there's more bias there for whatever reason. And one of the reasons one of the things we suspected might contribute to that was that there's kind of longer durations, generally speaking, for each word, and basically intonational phrase for infant-directed speech as well. So you maybe get sort of more of a sense of a break between the first word in each phrase and the second word, the peach versus colors, there might be more of a break in between those two because their durations are longer and the pause between them is longer as well. So if there's more of a break, maybe you perceive that as more of a noun verb phrase, just in general, than an adjective noun phrase. Who knows exactly, but one of the things we did to follow up on this study was to sort of transplant the durations of the individual words from one utterance to the other. And that's actually what the homework is about, that we're going to do for homework number 7, is comparing sort of the raw the responses to the raw original recordings we made of mothers speaking to children and to adults. And then we ran another group of listeners in a separate study where we transplanted the durations between infant-directed and adult-directed speech so that you could get sort of the prosodic or pitch cues normally associated with infant-directed speech, but with the adult-directed durations, which are normally shorter, and then vice versa in another set of stimuli where you had adult-directed speech pitch cues plopped on top of adult-directed or infant-directed speech durations of particular words and syllables. So I will say more about that when I walk you through the homework, but that's kind of where the homework comes from, or at least the data for it come from. And so I'm just setting the table for that at the moment. Before I get into that, I wanted to give you one other example of where using D-prime analysis or signal detection theory could come into play or be handy for you when you're analyzing the results of response data. And I'll present this example from the world of categorical perception. So those of you who have taken my 441 class or who are in the middle of taking my 441 class have either done this experiment before or may do it quite soon. This is from a task called an AX discrimination task, where you just hear two stimuli. And those stimuli may be the exact same token twice, or it may be two different tokens, acoustically at least. And your job is to determine whether the two tokens you heard are the exact same or different in some way. So we do this in class in 441, and I've collected a lot of data about people's responses over the years because I've been doing it ever since 2007. So I've got two tokens here, which sometimes appear in the same pairs and sometimes appear together in different pairs. So the tokens are token number 1 and token number 3. This is what token 1 sounds like. So this categorical perception experiment is about stop vowel tokens. So it should sound like there's a stop at the beginning of these little sounds, but it's a little bit ambiguous as to what that stop is. I'll play them both and I'll explain a bit more about that. Right, so if you're like me, you probably heard both of those as like a ba. If you listen super closely, you might be able to pick up on the fact that they are slightly different from each other, acoustically speaking. Like maybe this one sounds a little bit more convincingly like a ba than this one. I don't know. Maybe you get that percept, maybe you don't. In any event, in the AX discrimination task, what we do is we pair up 1 and 1 together and two, like a two token pair, and say, well, are these two the same or different? And then you would normally respond same, like 402 times people have responded same. Only 16 times people have responded different. You have the similar sort of same pairing of 3 and 3. Like that. Most of the time people respond the same to those. And in fact, even when you present both of these together in either order, most people respond same because they do sound pretty similar, right? But you get more different responses in that case than you do over here in the actual same pairs. So if you want, you can actually kind of combine these pairs into same different confusion matrix. So it'll look like this, where we have same pairs, either 1, 1 or 3, 3. Just adding up these numbers here, we get 785 same responses, 51 different. And then you can count all the numbers from the different pairings over here and plot the number of times or present the number of times you get same responses to those or different responses to those. And based on simply this 2 by 2 matrix, you can calculate a value of D prime. And I think I do that here on the next slide. Yeah, so we'll assume that hits are same responses to the same pairs, and then false alarms are same responses to different pairs. So this is a correct hit or the number of correct hits here, and these are the number of false alarms down here. And then we just run the math appropriately. So we need to know the total number of times that these stimuli have been presented to listeners, and then how often out of those total number of times you get hits or false alarms. The same pairs are presented more often. Unfortunately, these numbers don't totally work out, but we don't need to care because all we need to get out of this is the percentage or proportion of hits and false alarms. And on the basis of those numbers, we can simply calculate D prime. So the z-score for this percentage of hits, 93.9%, is 1.546. And the z-score for the percentage of false alarms, which is 77.8, winds up being 0.764. So if we go through the math again, calculate D prime, we just want to know what the difference is in terms of z-scores between these two numbers. It winds up being 0.782. All right, so there's a D prime number for you about how distinctive these two tokens happen to be. And remember, they're probably acoustically distinct for you, but maybe not necessarily phonetically or phonemically distinct, depending on how you hear them. There's also a way that you can calculate beta or the bias measure here. I'm not going to walk through all the different specifics again, but I'll just say that once you plop these numbers in here, you get a beta score of negative 1.155. Obviously, there's a lot of bias towards responding same to these stimuli, just because they're pretty close acoustically, so they sound the same. So the negative number here means more bias towards same responses. We can do the same thing, and this is the last example I'll give you for now. We'll do the same thing with a couple of tokens that fall more convincingly across a perceptual category boundary. So I'll let you listen to these, and before I play them, though, I'll say that they differ acoustically kind of in the same way that the first two tokens differed. When we just measure things in the acoustic domain, they look like they have the exact same difference, but they might actually sound different to you in this case. I'll play them a couple times so you can make your own judgments. And again, if you're like me, you hear this token number 4 as basically a ba, and this one as more like a da. So it sounds more like a B at the beginning here, and a D at the beginning there. Maybe you get that, maybe you don't, but it doesn't really matter. As we know, there's variation in everything, so you can contribute to a certain extent, and I can contribute to a certain extent, but we'll get a clearer picture the more data we get from more people. And if we do that, like I said, I've done this a lot in 441 over the years. For the same tokens, like presenting these two twice in the same pair, or this one twice in the same pair, a lot of people respond same. Similar here. About 90%, which is a little bit down from what we saw before, but it's still a pretty high percentage. But the different pairs, like that, a lot more people are responding different there. So again, kind of analyzing this the same way where we think of this as our hits and this is our false alarms. We know the total numbers of times that these stimuli have been presented. And so dividing 756 divided by 836, we get 90%. Plus change, and then 101 divided by 418 gives us about 24% for the false alarms. If we calculate D prime again, we find a much bigger D prime than what we got before. It's a value of 2. Before we had 0.7 something, right? 0.782. Yeah, so D prime has gotten a lot bigger. These are a lot more perceptually distinct for our listeners, even though acoustically they're the same. What's going on there? And then also, if we calculate B beta, interestingly enough, we find there is still a strong bias towards responding same here. We have a higher number of tokens on this side, but we've been able to kind of filter that out from the D prime considerations itself. So we know there's still greater distinctiveness between these two token types or these two pair types, but the bias is more or less still there. Because before we had negative 1.155, so the bias has gone down a little bit. It's 1.004, but it's still a strong bias towards responding same here. I was originally going to, that's all I'm going to say about categorical perception, just an example of how the math works for this kind of data. And you could imagine pretty easily how you might get similar 2x2 matrices from your own work, whatever it might be. Originally, I was going to just roll on into talking about the homework after finishing this video, but I've already talked a fair amount for this particular video, so I think I'll just add it to the previous lecture videos, the two I'd already made on signal detection theory, and I'll just separate out the homework. But the homework, the next one, is going to be based on that first experiment that I talked about, the peaches coloring on the walls, or maybe just the peach colors on the walls. So you can stay tuned for that, and I'll leave you with these funny pictures, which I think are still pretty amazing. I had nothing to do with them, but I'm glad to be able to present them to you because whatever, kid stories are fun. All right, I'll see you in a bit for homework number 7, the description for that. That's involved, so make sure you watch the video, especially if you have any time to do so. All right, see you soon.